Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We're here live at Evergreen Elementary School, home of the Eagles, and today we're all here to do the math!
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott, and we're glad you joined us today. And we want to let you know, on the day before Halloween, math is not scary. Please give us a call. Let us know what your question is, and we can help you out with that. The number here in Bakersfield is 636-4357. Even if you're over in San Luis Obispo, you can give us a call. The number is toll-free, 866-636-6284. You can even email us your math question, and we actually got an email today that we're going to solve on the program. The email address is dothemath@kern.org. And you can watch the show online, dothemathonline.net. And of course, if you're any part of social media, we have accounts on Facebook, Instagram, Twitter, and YouTube.
If math is not scary on the day before Halloween, will it be tomorrow?
Tomorrow, you have to wait and see.
That's
Got
a
to
whole
tune in and
different
find
story.
out. That's right.
We're going to make Mary Lou do all sorts of different problems tomorrow while
That's
she's
gonna
in
be
here
great.
tomorrow afternoon. Anyway, we do have phone tutors available until 5:30. And we do have a very special guest in studio. We'll be going out live to visit with Devin and those school members out there at Evergreen once again in a little bit. But before we do all of that, let's first take a look at today's Math in the News. So with the end of October and Halloween coming up and Thanksgiving and things like that, a lot of people decorate their houses, and there are a variety of things that they use. So what are some things that come to mind when you think of fall, autumn, Halloween, Thanksgiving, things
Red,
like
yellow, orange, pumpkins,
those are the
leaves.
colors, pumpkins, right?
Yeah, the little multicolored corn on the cob. That's good.
Yep.
That's a good
all
fall
that,
decoration.
All that kind of stuff,
Yeah.
right? Then there are some people, they get hay bales.
Okay,
Right,
there you go.
and they put those out and they decorate with those a little bit.
Right.
And then, you know what? I was looking at something the other day, and for people that don't have a lot of space to do their big gardens or something like that,
Right.
you can take a hay bale, right? Water it, get it nice and hot inside, right? Get
Right.
that thing going, and dig out a little bit of it, and you can put your plants right in that.
I've heard
And
about that.
then
You got
that
the
is a
insulation, right?
contained spot right there.
Yeah.
It's not down in the dirt and things like that. So I thought that was a pretty clever idea. I might want to try that. And you can bring me a hay bale.
All right, we'll
So-
see what we can do for
All
you.
right. So anyway, speaking of hay, I saw this article and I figured, well, let's go ahead and see how we can apply this to some mathematics.
Okay.
So you've heard the story, finding a needle in a haystack.
Right.
So if
Common
obviously
expression.
something is hard to find, it would be like finding a needle in a haystack.
Right.
All right. And here's a photograph of a guy finding a needle in a haystack. Okay.
They caught him at the moment he
Right.
found it.
So you can see, I mean, just an average needle right here. And most people are familiar with needles, even kids, you know, I mean, 4th, 5th, 6th graders, they're familiar with needles because they've
A sewing needle. right?
vaccinations and
Right.
things like that. So they know that they're very thin, pointy, and hard to find if you're looking in a haystack.
Right.
All right. So let's go here. And this guy, now let me give you a little background here.
Yeah, please tell
Okay.
us what's going on.
So a guy searched through a haystack for a lone needle and was successful. That's what sparked my interest.
All right.
Okay. This guy's name is Sven. He's not a knitter nor a farmer. Okay. He's a performance artist.
Okay.
Okay. Now this is in a museum. Okay, this video that we're going to watch for a moment right here.
All right.
All right. So let me just go ahead and play this right here. And you can see what he's doing. Okay, so the museum's going on with the regular business. And what he's doing is he's picking up a handful of hay.
Okay.
And what he's doing is he's crumbling it in his hands. Okay. And if there were a needle in there, he would be able to find out pretty quickly
okay.
by getting
he's going by feel.
Prick with it, right?
Yeah.
So he's just taking this, squishing it all up, and then putting it in another pile, so the smaller piles you can see in the background there. So I was like, all right, so how long is this taking this guy
Right.
to do
I was
this
going to
thing,
say,
right?
how long is the video going to go?
So
here?
he's sitting there, and this guy was doing this. Now, if we look down here, you can see, okay, so 6 hours. So there's over 6 hours of pure entertainment here that you could watch this thing through, all right? So anyway, this guy is just doing this nonstop. The museum's going through their thing and doing that. So I figured, all right, let's go ahead and see what's going on.
Right.
How long do you think it took him to find that? He did find the
Random
needle in the
guess, 6
haystack.
hours and 41 minutes?
No. That's how long the video is right there.
Oh, part of it's
So-
a celebration at the end after he found it, right?
Well, there was only 6 hours filmed.
Okay.
Let me put it to you that way.
Okay, that's fair.
All right. So I'm not saying it did happen within those 6 hours. They only filmed 6 hours. Of it.
Okay.
So how long do you think it took for him to find?
Oh, man. Yeah, I don't really have a good guess on that. I'm not a very good estimator on needles and haystacks. I'm sorry. Can you give us a hint?
Midway through the second day,
The second day.
18 hours.
Oh, goodness. All
Okay.
right.
Ding, ding, ding. The man found it.
All right.
And a little blood on his somewhere. When
Right.
finally squishing that all up and finding it. So I figured, all right, that's nice, but it's not really anything to do with math
Right,
yet.
right.
So
We gotta
let's
do some
go
math
ahead
here.
and get into some math now. So
All right.
the odds of finding that needle in a haystack.
Okay.
All right. So we'll just talk a little bit about probability. So another way to express the chance of an event occurring is with odds.
Right.
So the odds of an event occurring is the ratio that compares the number of ways an event can occur to the number of ways it cannot occur. So the odds are the successes to the failures.
Okay.
And even though we don't have a number for that, that's one thing that you can talk about. Like, oh, what are the odds of doing it? Well, how do you figure out odds?
Right.
So we take these successes as opposed to the failures, and that's how we get odds and probability.
So you could take one handful, which is all that would be the success, right? Out of however many handfuls that he had to
He
use
took
to
to
go
do
through
it.
the whole
So
entire
if you
pile.
wanted to go handfuls, all right, I had one handful, did this, and that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. In studio with us right now, as promised, we have our very special guest, Jazmin. How are you?
Good.
Why don't you let everybody know where you go to school and what grade you're in?
I'm in 6th grade and I go to Berkshire Elementary.
And how is Berkshire?
Good.
You like it?
Yeah.
Have you been there for a little while?
Yeah.
Or is this your first year?
I've been there since kindergarten.
You've been there since kindergarten. All right, so you've been there
Yeah.
since kindergarten. You're in 6th grade, so you're going to be all through with Berkshire next year.
Yeah.
Is that going to be a good thing, or you're not looking forward to that at all?
Kind of and then kind of not. I don't know.
So are you excited about junior high?
A little bit.
A little bit?
Yeah.
What do you like best about 6th grade right now?
I like the math.
You like the math that you guys are doing. What kind of stuff are you guys doing in class?
Oh, like the ratios and like,
Okay, so you like doing ratios, you kind of getting that stuff right now?
yeah.
Good. Well, you know what? We're going to have you work with decimals and dividing them.
Okay.
So I'm going to throw you way off course here, all right? So head on over to the board real quick. This is actually one that was emailed into us, and once again, Scott did give us the email at the beginning of the program, dothemath@kern.org. And this one is for Jose, and here's the problem he wanted. So you can start way over on the left, whichever one of you is writing this. 3.43 divided by 0.035. And if the both of you could work on that, solve that, it would be a big help to Jose and everybody else watching.
All right, Jazmin, where do you want to start with this one?
Like putting it inside.
Yeah, we got to do that thing where you have the little inside the house deal, right? Now, which number goes inside and which number goes outside?
The 3.
Okay. That goes inside. All right, so the first number that you see in a division problem goes on the inside. And the other one, only one other place for it to go, so that's kind of nice.
Wait.
That's all right. So we got 0.035. Give yourself enough room there.
Oh my God.
0.035. Okay, what do you have to do before you start this problem?
Move the decimal.
Yeah, tell us about that decimal a little bit. The outside number has a decimal, right? And we would really like this problem to not have a decimal on the outside,
Yeah.
right? It's okay to have a decimal on the inside, but on the outside, it'd be better not to have that. So,
Yeah.
what do you want to do?
Move the decimal.
Okay, show us how to do that.
That.
There you go. Good. So, if you have $17.50, can you just go ahead and start moving the decimal over here? And now I have $1,750. Good for me. Hey, I just found out a way to get
No.
rich. No? Well, that's what
No.
you just did. Tell us why that's okay to do that.
Because at the end, you'll move back.
Or you want to move back at the end. Okay, let's see what happens here. So you got 35.
Yeah. And then. No. Or.
Okay, 35 doesn't go into 3. 35 doesn't go into 4.
It goes into 343.
343, yeah. What are you going to do with that one?
I'm gonna.
That's a big one,
So
huh?
I'm going to give you a clue here. It's not going to go 10 times because that'd be 350.
Right.
So it's going to be 9. So
that
figure out 35 times 9.
Gonna do that on the side there.
Yeah.
Good. There you go. So we're trying to figure out if this number up here is 9.
And then. 27. That.
So 9 times 3 is 27, right?
Yeah.
Good. And then you're also adding a 4 into it. So talk us through this. Tell us what's going on, because I can see that your mind's definitely working, but not all of us know what you're thinking there.
Okay,
So 9 times 5 is 45. You put down the 5, carry the 4. 9 times 3 is 27.
Plus.
Plus 4 more. That's right. What do you get now? 27 plus 4?
31.
31. Okay, good deal. So you got 315. Where does that number go?
Right here.
All right.
And then subtract.
Good. And then we got some subtraction going on. That's it. Okay, canceling a little stuff out here. Borrowing over there.
8.
Good. There's a good start.
2.
2. 28. What do you want to do that?
And then 28. And then I.
Oh, you're going to add a 0 so we can keep going. Good idea. So you can add a bunch of zeros if you needed to, but we're only going to need 1, I think. How many times is 35 going to 28? Well, here's the way I'm thinking of it, right? 35 times 2 is 70. Does 7 go into 28?
No.
28 divided by 7? Can you do that?
Oh yeah.
Yeah, what is that?
4.
That's 4, right? But it's not
So
quite 4 because
40.
remember it was 35 times 2, right? So what's 2 times 4?
8.
8. There's the number you want up there. Jazmin, you're looking at me like you don't believe me. I want you to, over there on the side, show me 35 times 8. My educated guess of the day is going to be that that answer is 280.
Okay.
We'll see if it works. 8 times 5?
40.
40, good.
Carry the 4. And then 24.
Good.
Plus 4 is 28.
Oh my goodness, how does that happen? That's amazing. So I'm going to take your number and put it right under here, 280. And when you subtract,
It's 0.
there you go, nothing left. Okay, so now at the very beginning, remember you moved that decimal. And now we got to do something else with it. Because you're going to teach me. When I used to do these problems, I didn't do it your way. But I have a feeling you know what you're doing. You moved it to the right, and you're going to move it back.
Yeah, and I moved to the left 3 times.
Okay. Wow, 0.098?
Yeah.
Is that it? Okay, so you got a 0 here. So if you multiplied 0.035 times 0.098, you think you'd get 3.43?
And we're going to hold that right there.
Yeah.
We're going to have you guys check that in just a moment because
I like
you've
it.
done some great division. But now we're going to check and see what happens with that in just
Good
a
idea.
moment. But right now we've got an opportunity. We're going to head out live and visit with Devin.
Hey, thanks a lot, Mike. Back here at Evergreen Elementary School, home of the Eagles. I'd like to introduce you with our working team today. We got about 20 fifth graders here at Evergreen. Say hey, everybody. Hey! I thought I was going to have one person say everybody at the end because it's literally what I asked them to do. So I love that we got this very warm and playful room here. Everybody's really well spaced out. Let me have everybody kind of come in here. I feel like I'm going to go back to kindergarten. Look at this, got a rug with letters on it. I'm going to go ahead and have a seat. Why don't you guys come on down with me here? I don't get to do this often, and I don't know if my insurance is going to cover this if I try to get back up too quickly. So thank you for joining us here on the carpet. Oh, this is like kindergarten again, huh? Do you guys like kindergarten? Yeah. Everybody loves kindergarten except one lady over here. So here's what I want to talk about today with our fifth graders as we kind of turn back the clock. I want us to join together for an activity that I call Same or Different. So what you're going to see on the board here are going to be two images that are mathematically related. They could be expressions, they could be an algorithm, they could be conceptual models, they could be visual or image, could be anything. And what I want you to do with your groups, because they've already set up, you guys are in groups of 5. After these visuals go up and you take about 15 or 20 seconds to think to yourself about what you see, go back to your group and I'm going to have you answer a very specific question. Are we ready? Yes. I know you guys just got comfortable on the carpet and now I'm making you go back, but we're going to wait here for a second, okay? We'll hang out here, take a look at the board, and observe these two visuals. Take about 15 or 20 seconds to look at these two. I wish you guys could see what I would see. All these gears turning, the wheels spinning. What I would like you to do back at your groups is discuss with your teams what is the same about both of these. Are you ready? Stand up, back to your groups, go! So right now our teams are looking at both of these figures. And if you have been exploring multiplication in depth, especially at the 5th grade level, even as far back as 4th or 3rd grade, you might recognize this figure here as an area model. Now an area model is very helpful with multiplication because it allows us to break down pieces of multiplication. You may also be familiar with this. Now, we didn't reveal what operation this involves, but you could possibly guess. However, we did not include the product of these, just the pieces. And I'm really curious to see exactly who puts together the idea that these both represent the same product and the same sums. So, let's figure out what everybody had to say here.
And 40 times 30 equals 120, and 40 times 40 equals, I forgot.
Now, somebody over here said something really interesting. You guys can keep going. You don't have to wait up for us. There's a lot that you can notice, so keep that conversation moving. Somebody over here noticed that there are some similar values across the way. I believe it was you that said something about 170? Yes. What did you notice about 170 appearing?
170? Well, I just multiplied it in my head, and I see the number down there, 1360.
Okay.
Yeah, and I just see it. I'm just the only way you can get that number is by multiplying.
Okay, so you recognize that both of these are multiplication related.
Yes.
Okay. Now you mentioned 170, and that's one of the numbers that appears on the left side. Do you see 170 appearing anywhere on the right side?
I do not.
Okay, let's see here that we wouldn't see 170, right? Well, so let me ask this then. How, if this was multiplication on the left, how would we get 170? So what's interesting is that we recognize this as multiplication, but how that works and why it's multiplication we can have a conversation on. So what else did we notice that was the same between these two? Let's start off and visit each group very quickly. Go.
That one's multiplication.
They both deal with multiplication. Okay, there's a lot of inference. What tells you that they both deal with multiplication?
Because that one is standard algorithm.
Okay, we have a standard algorithm for multiplication on the left side. What about the right side? Does anybody recognize that right side as anything related to multiplication? Right back here. What do you call that again?
Area
So
model.
this is an area model, okay? So they both deal with multiplication, but they're different in that this is a standard algorithm and this is an area model. Is there one more thing that you recognize about both of these out of the same? Let's go to this group over here. One more thing that's the same about these two.
They both use the same numbers?
They both use the same values. Which numbers are the same in both of them?
40 and 30.
So
45
you see
and
a
30.
40 and a 30 here. Do you see 40 and 30 appear within here in any form? Because you're right, there is a 40 here and a 30 here. And when we come back, we're going to dive deeper into the similarities between these two models. But for now, we'll send it back to the studio. Mike, take it away.
All right, thanks for that, Devin. Too bad Devin wasn't here. We could say what's the same and what's different, you know? What's the same, what's different. So, anyway, we do have phone tutors available until 5:30 this afternoon, as we do most Tuesdays and Wednesdays throughout the regular school year. As a reminder, we do have a very special contest going on for some of the students in San Luis Obispo County. There are two schools going head-to-head. And you can see the two schools right there. The school with most calls wins. And what do they win? They win a tour of Doc Bernstein's Ice Cream Lab's secret facility where they make the ice cream.
Where is it?
Oh, I
it's
can't
secret.
tell you where that is.
Apparently it's secret.
It's over on the Central Coast. It's a secret location with secret things inside. And I'll be there, of course. 'Cause, you know, somebody's got to help bring the kids around, you know.
That's right.
Sample things.
That's right.
Anyway, Jazmin, we're going to keep working on that problem that you and Scott were working on. So go ahead and finish this up for us and talk a little bit more about the decimals and what you guys were finding out.
Okay, so I forgot to move the decimal right here.
Okay. So tell us about the decimal at the beginning. At the very beginning, you made the outside number into a whole number, right?
Yeah,
And how many times did you move the decimal?
3 times, so
Gotcha.
I'll move this one 3 times.
Can you show us? Good job. So the decimal's right there at the very end of that number, right there. So where's the decimal in your answer then?
Right here.
That's it. So nothing to really change. All the math was wonderfully done. You just got to know where the decimal is, and it makes a big difference, right? Between $17.50 or $1,750. Decimals make a really big difference. So I'm glad we got that at the very end there. So Jose, great problem to ask, and the final answer on that one is 98.
There you
Nice
go.
job.
Nicely done. Erase the board. Jazmin, since you're up there and comfortable, we'll give you another problem.
Round 2.
Now, you don't understand, Scott, that a lot of the kids that come in here, they're actually in 2 math classes.
Ah,
Right?
nice.
You have 2 math classes going on right now, one for gate and one for regular class.
Yeah.
Right? So we're going to do one of the other problems that you're working on. All right? Here we go. All the way over to the side. -3 equals -1/2.
Wait, 1/2.
Yeah,
That's okay, just put it
-1.
over
So
two.
just put a fraction bar into that. Yeah.
That's all right.
So 1/2.
Okay.
Yeah, if you want to get
Keep
rid
on
of
going.
yeah, so somebody doesn't understand. Okay. And then open up a set of parentheses, n minus 6, close parentheses, and solve that if you would, please.
Okay, so if you multiply them, it'd be
Oh, so tell us where that.
Happened.
Whoa, that's great. Good work there. Tell us what happened there. What did you do?
so you multiply 1/2 and n.
Okay, so we're going to use the distributive property, right? And I like the fact
Yeah.
that you took the sign with this number. Take that whole entire number, and you're going to multiply times n. You got that part. And then what?
And then you take this number and multiply it with.
Good for
the-
you. Okay, good. So what do you get?
So then 6 times 1/2 equals
Yep.
2/6, which equals 3.
I'm glad you did the math over there. Nice job.
So then it'd be positive.
Yeah, that part of the board doesn't like us. Go ahead and you write the 3. I'll see if I can write the positive. Oh, man. That got all crazy on us there. That's okay, though. We know what's going on. +3.
And then
It's black
bring-
and red.
Bring down the -3.
Good. Tell us a little bit about the +3 first. Where did the positive part come from? We got the 3, no problem there.
Because negative and negative equals positive.
Good, gotcha. Now, one of the other things I like to do on my equations, I like to split it in half because I have a feeling you're going to start doing the opposite of this, of whatever it says, right? Show us what's happening next.
So then you would take away the numbers so that you leave the n. So you would do -3
Okay,
on this side and -3 on this side.
good.
And then these cross each other out, and then you bring down the half and then n.
Good, there you go.
And then
Aha,
these,
there's the
these
problem right there.
equals 6
Gotcha.
positive. I mean, not positive.
Oh, she changed it up. Good for you.
Yeah.
Oh, things got a little crazy on us there, huh? We have an equal sign here, no problem there. And we have this one you said is going to be a negative, right?
Yeah.
So amongst all those green dots, we have a -6. Tell me a little bit about why -3 minus 3 is -6. Because a lot of students will do exactly what you did. They'll either put +6. Sometimes I'll even have my students say that that's 0, though, cancel out. But we know that this was 0, right? +3 minus
Yeah.
3. Can you explain to us why -3 minus 3 is -6?
Because they're both negative, so if on the number line
Mm-hmm.
you have 3 negative, you add 3 more, but it's still negative.
Oh, you go down, down.
Yeah.
Gotcha. Okay, what are we going to do with this last -1/2 part?
So then you divide by 1/2,
Good.
and then divide on this side by 1/2,
Nice job.
and then
Now, before you keep going, are you dividing by 1/2 or something different?
I thought you might guess that.
by 1/2.
So we have a negative and a negative, and we put a negative sign there, right?
Yeah.
And you got a negative here, and you put a negative over here. Tell me about that 1/2. What's the sign on the 1/2? Look right here. What's the sign on the 1/2?
Oh, negative.
Good. So let's go ahead and make all of those things that you're dividing by also a negative. Okay? So here's one thing I like to tell my students too. What is a negative divided by a negative?
Positive.
It's a positive. So before you do any math at all, you know the answer is going to be positive, right? That's a good thing. So we don't have to worry about the sign now. Now you can just do the math part. Can you do over on the side there? What is 6 divided by 1/2? There you go.
And then
Aha, I like how you made the 6 into a fraction as well.
you're supposed to keep it,
Keep it.
change it,
Change it.
and then flip it.
So you flipped over the second one. What's that called in math, by the way, when you flip over a fraction? Remember that word?
Using the reciprocal.
Reciprocal. Nice job. Well done.
And then it equals 12 over 1, which equals 12.
12. All right. So we have over here, we have 12 equals
And
n. That's it. Now, how could you figure out if that's the right answer?
you can check it.
You could check it. What does that mean? What do you do with that?
Use 12 where it says n and then check it.
Okay, we'll do a little mental math here. This one you're saying goes right in there, right?
Yeah.
So what's 12 minus 6?
12 minus 6 is 6.
6. What's half of 6?
Half of 6 is 3.
That's right. It's 3. But we have a negative 1/2 of 6, and so we get a negative 3. And it all works out pretty well. Nice job. Well done on that problem. I like it.
Excellent work right there. And for such outstanding work, you've got yourself a free meal courtesy of our friends at Grill & Burger. Well, congratulations on that. I think you've got quite a selection of food over there that you can choose from, so nicely done. Hey, we do have phone tutors available until 5:30. We'll be back and do more right after this. Today we're on the Central Coast. We're at Grover Beach Elementary, home of the Golden Gophers, and we're here to
Do the
And we're back with students from Grover Beach Elementary. We've got 4th graders and 6th graders in here. And here we're going to go over some terminology as we're working with these 3-dimensional shapes. All right, so with you and your partner, let's look at these together. So it says they can be described in 3 different ways. Faces, all right, the sides of the shapes. So do you guys see where the faces are? Just like when you made the cube earlier, the sides that you were looking at, those are the faces. All right, the vertices are the corners. All right. You guys see where the vertices are? Those are the corners of the object. And then the edges, that's where the faces meet. So when the two come together and you click them together, that's the edge. Are you guys all good now?
Yeah.
So use that as a reference, and now I have a challenge for you. So, are you ready for the challenge?
Yes.
All right. So before you could build anything you wanted to and just kind of see how these worked. Now you're going to have to build exactly what this wants you to. It's only going to tell you how many edges, how many vertices, and how many faces it has. You then have to make that object. Are you ready? All right. So we're going to give you that one. Not yet. We're going to have competition. You got it right, sister. Here we go. All right. So you're going to get that one. And we're going to give you guys this one. All right. So here's what we're going to do. Working together as a team with your partner. All right. You want to take a look when I tell you to, what the challenge is, and then start working on it. You have your reference paper here so that you can remember what the faces are, the vertices, and the edges. I only have one question for you. Are you ready?
Yeah.
Yes.
Really ready?
Yes.
Definitely ready?
Yes. Yeah.
Do you want to wait any longer?
No.
Then go!
It's an octagon. Okay. No, it's a cube, actually. 8 edges. Yeah, it's a cube.
Are you sure it's a cube just by looking at that? You better make sure.
Faces. How many faces does this cube have?
This one has.
Here, well, it doesn't show all of them, so let's.
It has 5, so it'd actually be us. They have 4, and they have.
Yeah, they have 4 faces.
And they need 4 vertices, which are the corners.
So start building something.
So we have this. So not actually.
So remember, what you're doing is you're laying out a net, and then when you fold it up, you want to see if it will produce what. So you want to build something that's going to have 8 edges, 5 vertices, and 5 faces. So here's a clue. If it has 5 faces, how many pieces will there be?
5.
5. Right? So you know there's not going to be any more than 5 pieces.
So we could use squares.
No, because that.
That's what you guys are going to have to decide on.
I don't know if this is right. Let's count them. So it needs to have 8 edges.
2, 3, 4. Wait. 1, 2, 3, 4, 5.
The cube has 6. And it's not right because the cube has 6 faces.
Oh my god.
Right, see, the cube has 6 faces, you only want 5. So can it be a cube?
No.
No, can't be a cube.
How about this?
You're done? Let's take a look at what you guys did. All right, so let's see if it satisfies it. First of all, let's start with the easy part. 5 faces.
1, 2, 3, 4, and 5.
Perfect. 5 vertices.
1, 2, 3, 4, and 5.
Perfect. 8 edges.
1, 2, 3, 4, 5, 6, 7, 8.
Perfect. So you satisfied that. What is that called?
A pyramid.
What type of pyramid? Look at the base. What shape is that?
Square.
So it is a
Square pyramid.
square pyramid. There you go. Nicely done, boys. You have completed that. You may go ahead and work on any other shape you like.
What is it?
All right, so the students in 4th and 6th grade are working at this from Grover Beach Elementary, working on the 3D shapes, practicing a little bit with determining faces, vertices, and edges to come up with the exact. And what is that? What type of pyramid is it? So here's how you can tell. Look at the base. So we know it's a pyramid. And when you want to know what type it is, look at the base. What shape is that? So it's a triangular pyramid. Nicely done. You guys have satisfied that. 6 edges, 4 vertices, and 4 faces. Nicely done with the students from Grover Beach Elementary. Oh, lovely school over there on the Central Coast. Thanks again to Mr. Snyder and the staff and students at Grover Beach Elementary. Hey, we do have phone tutors available until 5:30. We have Jazmin working in studio while we're waiting to get to her again. We're going to one more time head back out to Devin and see what the students are doing now.
But that's the way this first.
Hey, thanks a lot, Mike. Back here at Evergreen Elementary, we have continued the conversation, and I think the conversation has stopped since they knew that we came back here. But while you were gone, some really interesting connections about similarities between the two figures that we'd explored with our same different prompts. So we're going to revisit that and then get into the different parts. So let's take a look and see what we've built up here. Welcome back, everybody. So I want to share with our audience at home some of the similarities that you identified with our same or different prompt here regarding these two representations of multiplication. So I want to share some of the things that the groups came up with. We had a group identify that both end up with the same product, and that was a good reasoning sense. The idea that if you're multiplying two numbers together, it doesn't matter how you do it or in what order, you have to have the same product. Also, that both involved using addition. And I thought that was very insightful, that both involve you adding some numbers together to end up with that product. We had one group identify something unique about the set of factors involved that appeared in both, the fact that both use one odd factor, 45, and one even factor, 34. And that makes sense because, again, we both have the same factors being used in both figures. And then we had an interesting observation that both involve adding 170 and 1360, or 1,360. And so that might not be immediately apparent in the area model, but if you look at what happens when you multiply 30 and 4, oh, I gotta go back here. When you multiply 30 and 4 with, oh, there we go, with, thank you very much for calling this out, breaking through the fourth wall here, the mysteries of television have been shattered, ladies and gentlemen. But when we multiply 30 and 4 times 5, we end up with 30 times 5, which is 150, plus 4 times 5, which is 20, and when we add these together, we get 170. So, logic would state that we could do the same thing up here with these two and end up getting 1,360, and that works. As we left for break, we started a conversation, and it's been going on for about 5 minutes or so. Now that we've identified what is the same, we want to discuss what is different. And obviously, the first thing they identified that was different is the fact that one is a standard algorithm and another is the area model. But I was curious. I wanted to see what else is different. So let's go back to our groups and see what they have to offer. Let's start where we ended last time. We'll go here, okay? What was something you identified as a difference between those two figures?
They're both a different way. They're both solved a different way.
So they're both solved a different way. Could you kind of explain a little bit more on what you mean by that?
I mean, like, you're trying to find the problem of algorithm.
So let me ask you how you would start with the standard algorithm. What would be the first step in solving 34 times 45 in the standard algorithm?
Starting from the right and...
Okay, so it sounds like you're starting off by multiplying 4 times 5. That's your first step. What would be your first step in the area model?
by multiplying each cube.
So what I'm hearing is it doesn't matter which two numbers you multiply first in the area model, but the standard algorithm almost forces you to multiply the ones places together. Whereas in the area model, you can start wherever you want. So that's a really interesting connection. We'll get that up there in a moment. Let's visit our group in the back. What is different about these two figures?
Something we said is that in the standard algorithm, it has 34 and 45 just together, but in the area model, it separates the 34 and the 45 by tens and ones.
So what you recognize is that the area model breaks apart your factors by place value, but the standard algorithm doesn't. It brings that value together as a whole. So that's an interesting connection. Let's go to our gentleman back here. What is a difference that you've identified?
The aerial model is less, and then the standard algorithm is higher.
So what do you, explain what you mean by that? Less or higher? Can we be more precise in what we mean by that?
Well, the aerial model has the less numbers.
Okay, so what I hear you saying is that the numbers we end up adding together in the area model end up being smaller than the numbers that we end up adding together in the standard algorithm. That's a really interesting look at that, and it's the reason why so many people love the area model. One more very quickly, one more difference here.
This one has it shows the answers, but this one doesn't. You have to add this one up, and you have to put it the 34 and 45, and you have to multiply that.
So what I'm hearing you say is that most of the numbers have already been combined here, whereas you have to do a little bit more work to add some more numbers together on this one. So what this ended up becoming was a conversation about the pros and cons, the pluses and the minuses of standard algorithm versus the area model. So when we come back, we're going to bring it all together with a new way to make sense of multiplication. But for now, we'll send it back to the studio. Mike, take it away.
All right, thanks for that, Devin, and the students out at Evergreen, home of the Eagles. Like the girls' T-shirt out there, sweatshirt,
right.
And nice little promo for Evergreen out there. 636-4357 is the phone number. We do have phone tutors available until 5:30 this afternoon. Jazmin is in studio with us. She's a 6th grade student at Berkshire, and those are also Eagles, correct?
Yeah.
All right, that's why I was thinking. I was like, Eagles, I thought Berkshire were the Eagles
Nice.
also. All right, so we're going to do another one of the problems that you're working on, one of the equations, but this one's going to, instead of just one fraction, we're going to throw 2 in there. All right, so head on over to the board. Here we go. 27, and open up parentheses, 1/3 x
Ooh.
minus 1/9.
Oh, it doesn't like you, huh? That's rough. Minus 1/9.
Close
Little tag
parentheses.
team here.
Equals
Equals?
10.
Oh, all right, we can do this. All right, Jazmin, what's first?
I'll multiply them.
What are you going to multiply?
27 and 1/3.
Okay, so a little more distributed property, right? This one's going to
Yeah.
go here, and then it's going to go there. So maybe on the side there, can you do that problem? 27 times 1/3?
Yeah.
Of course you can. 27. Good. Times 1/3, and you made 27 into a fraction too, yeah. Now, do you do anything when you multiply fractions? As far as have you done any cross canceling before?
No.
No. Okay. Go ahead and see what you can do, and then maybe I can give you a little hint about how you can do some cross canceling.
So then
27 over 3. What's 27 divided by 3?
9.
9. That's right. So real quick, if you wanted to make this even faster, see how 27 and 3, you can divide both of those numbers by 3? So what happens if you divide 3 divided by 3?
3 divided by 3.
Yep, what do you get?
1.
1. What happens if you do 27 divided by 3?
9.
9. And so all I did was I made both of those numbers smaller because I'm allowed to do that. Now you just have 9 times 1 is 9 and 1 times 1 is 1. So you can do it within the problem. But your way works as well. At least we know that you have 9 there, right?
Yeah.
9 what?
9x.
9x, good job. All right, what's next?
And then 27 times negative 1 over 9.
Good, so 27 times a negative fraction. What is the answer going to be, positive or negative?
Negative.
It is, that's right. We'll put that there so we don't forget. Now, let's see if we can do this problem, and you're going to try this new skill that you just learned, this cross-canceling skill. Ready? 27 over 1, right? Sometimes it writes, sometimes it doesn't. You never know. Keeps you on your toes around here.
Yeah.
Yep, times, oh, there we go. Times, what do we have here, 1/9?
Yeah. 1.
Good, all right, you're going to make that into a fraction?
Yeah.
Okay, can you do this cross-canceling thing? Do you remember how to do that?
Yeah.
What can you divide 27 and 9 by?
9.
Good. So what's 27 divided by 9?
3.
3, good job. You do the bottom one. What's 9 divided by 9?
1.
Good. And now multiply straight across. 3 over 1 equals 3. Nice job. Look at that. Saves us a little time. Equals
10.
10. And I draw that line because you're going to do the same thing on both sides, okay? So when you take care of the 3, good.
And then,
And you do plus 3 on the other side of the line too. Nice job.
and then these cancel each other
Mhm.
out. It's 9x equals 13.
Ooh, that looks like a really fun answer.
Yeah. And then divided by 9.
Divided by 9.
And then these two cancel out.
They do.
And then x equals, and then
And that what
That's
you're going to
a
do,
set.
because I know that you're probably going to want to move that into a mixed number.
Right.
But on your paper, they want it as an improper fraction or in fractional form.
Oh, nice.
So you can leave it just as that 13 over 9.
okay,
Saves a little work.
yeah.
There you go.
Nice
Nicely
job.
done. Well done on
Now,
that.
if you really wanted to torture yourself, you can take that number and plug it back in, right?
She can do that later on, because
We'll
I've
check
got
it out.
another problem for
Even
you.
better.
So go ahead and erase the board.
Wanna do one more? Here we go.
Here we go. Do you have any idea on the amount of chocolate that the average person eats per year?
Yeah.
What do you think?
That
We'll just
erasing the
scoot up
pages
here.
isn't going to let you do it?
It's not working out so well. It's okay. We got lots
All
of
right.
room.
So about how many pounds of chocolate do you think a person eats per year?
I don't know. I don't
Take a
remember.
guess.
Maybe like 2 or 3 pounds.
Okay.
Yeah, that's a good guess, because it's actually about a pound or two per year.
Okay.
All right. 6% of cocoa beans are insect infested.
Uh-oh.
Groans from the crowd as well in the studio. 6% of cocoa beans are insect infested. Now, the insects are considered delicacies in many other cultures, though.
Okay.
All right. The Food and Agriculture Organization of the United Nations, all right, the nutritional value of the insects is very good for you. All right. They have cricket tacos,
Right.
which you can go and buy, right? There are places you can get these things. The FDA says the bugs are non-hazardous, naturally occurring, unavoidable defects. All right? So, here's what I'd like you to do. We know that 6% of the cocoa beans are infested,
Right.
out of, let's say, a pound. Now, how many ounces? Do you know, Jazmin, how many ounces are in a pound?
16.
16
for
ounces
you.
in a pound, right? So you'll need that information, all right? Now, if you have a pound of cocoa beans, how many ounces are infested?
16 ounces.
Well, that's if the
That's
whole
1
pound.
pound, right?
Yeah.
But 6% of the pound is infested.
So here's
So
our
how do you
problem.
think you
We
guys are
wanna
going to figure
know
this out?
6% of 1 pound, right? But instead of putting 1 pound, what can we put there instead?
LB.
What's that?
LB is the abbreviation for pound.
It is, that's right. So instead of writing 1 pound, what could we write instead?
LB.
We did. I did that already. But instead of writing pounds, we want to put in ounces, right? How many ounces in a pound?
Oh, 16.
16. There you go. Gotcha. So really what we want to know is 6% of 16 ounces. Can you figure out that problem?
Yeah, just divide them.
Is that right? What does that word of mean in math?
Divide.
No, try a different one.
Subtract.
How about multiply?
Oh.
Subtract could be less, right? We can have add and you make a sum, or the word and, but that word of means multiply. Then when we're doing this kind of problem, we want to change this percent to a decimal. Can you change that percent to a decimal? Good. So how'd you know it was 0.06?
Because that's the tens place and this is the ones place.
Okay, good job. All right, so let's see if we can multiply these two things together. 16 times 0.06.
This is 36 and then
6 times 6, good.
put the 3 up here. And then this is 6
6, and then plus 3 is 9,
Good.
and then you cross it out, and then it'll just be 0.
Yeah, the rest of it's just zeros, though, right? See, 0 and 0 and 0 and 0 and 0. So that line doesn't even matter.
Yeah, and then since there's 2 numbers behind the decimal, you move the decimal.
Good. So
2
can you write
times.
our final answer here? This is how much. This is how many ounces are infested. What's the actual answer?
96.
96 ounces.
Oh wait, yeah.
What's
wait,
your
no.
answer? Where'd your decimal end up going?
Oh yeah.
There you go. Gotcha. So do we even have 1 ounce worth of bugs?
No.
No, not even 1 ounce. But it's enough to be nutritionally
Almost.
significant, right? Because we know that those bugs are good for us. Maybe we should try to get more like 60% infested cocoa beans to make it better for us. Then you can get all the chocolate you want.
And one way you can think about this is you can think, all right, if I had 16 ounces and if I had 10%, all you have to do is move the decimal. So it would be 1.6 ounces.
Right.
So if we have less than 10%, it's going to be less than 1 ounce, right? So is 0.96 less than 1 ounce?
Yeah.
Right, so that makes sense, right? So that's what you can do, kind of just mathematically reasoning through what's going on, and then you can see that 0.96. Now, do you eat chocolate candy?
Sometimes.
Sometimes? Well, who knows? Maybe you'll get the good ounces and Scott will get the ones with the bugs in them and stuff like that, and add to his nutritional value and protein. Right
That's
there.
what we're giving out tomorrow at my house.
Is there a, oh yeah, lovely. Oh yeah, come on and get the infested chocolate with the bugs in it and stuff like that. Now, if you had to eat a bug, which one would it be?
Jazmin, what do you think?
I don't
Now,
know.
they talk
Grasshopper,
about
probably,
cricket
huh?
tacos.
Yeah, if you're going to do it, you might as well go big. Go grasshopper. You think?
You'd eat a grasshopper?
I don't think I would. I think I'm going to go for those chocolate-covered ants. I've heard about those.
Oh, all right.
Heard they're small enough, got a little sting, but nothing to worry about too much.
Yeah, nice little sting down the throat as it goes down there. Anyway, we'll carry on with this later on. We do have one more opportunity. We're going to go back out to Evergreen and see what Devin's up to.
Thanks a lot, Mike. Back here at Evergreen Elementary, wrapping things up today for another episode of Do the Math. And when we left, we started talking about the differences between those two representations of multiplication, the standard algorithm and the area model. And as we left, there was a conversation about which one we prefer. And it became a really rich discussion about the benefits and disadvantages of both of them. And so I dropped a mental rock on these kids when we were in the break. And the question I asked was, both are all right when working with whole numbers, but what happens when we throw a fraction into the mix? And I had that conversation and let the groups really brainstorm together about what would happen if you have to multiply a mixed number, that is a value that has both a whole number and a fraction, and you multiply that times a whole number. So I'm going to go ahead and throw out an example. I'm going to put an example, I'm going to create one on the board. And let's have a conversation on how we might solve that. Is everybody ready? So as I'm putting this on the board, why don't we come back around onto the carpet for one more time today. We're going to do 5 1/2 times 11. 5 1/2 times 11. Now, what did we talk about as far as ways we can multiply a whole number versus a mixed number? What were some of your ideas that you brought from your groups? What were some of the things you discussed? We got kind of stuck. There was a lot of great conversation. Let's start off over here.
That if you add like one more, it will become 6 wholes.
Oh, so if we had 6, that'd be easier to multiply, right? But we don't.
Yeah.
That happens never come to rescue us, although I want to hold on to that idea. How many people were thinking about the standard algorithm, what that would look like? Could we really do standard algorithm with 5 1/2 times 11? It'd be really tricky, right? So let's think about the area model. Could we try this with the area model? What would that look like? What would I have to set up for an area model? How would I draw that? Yeah.
We're drawing a box?
Let's do a box first, okay? So we're going to create a rectangle that we can now split up. Now we have our two factors. How could we split up those factors? Yeah. By 3. What do you mean by 3? Well, remember, like both of these ended up being the sum of these values, right?
By splitting them up.
So how could we, let's start off by, which one do you want to split up first? 11, right? How can we split up 11?
By just 10 and just the way the
10 and 1,
is.
you're absolutely, that sounds great to me. Let's do that. Let's do 10 and 1. Because 11 is just 10 plus 1. What about 5 and a half? How could we split that up? How could we split up 5 and a half? What are your thoughts? I know, right? How can we try it? What were you thinking? Want to help him out?
2.5?
2.5 is interesting. 2.5 is essentially 2.5. If we add up 2.5 and 2.5, 2.5, we get 5. But we still have that 1/2. I think there might be a more straightforward way, because you could do it that way if we bring in that extra 1/2. But how else could we split up 5 1/2 more friendly? What do you think? She's got it. Go for it.
5 times 1.
5 times 1, that gets us to 5, right? Think about what 5 1/2 is really equal to, right? It's just two numbers that we add together. So how would you split that?
2 plus 3.
Go ahead.
2 plus 3.
Well, that's just 5. We still have that 1/2, right? Yes.
I think it would be the 5 and then the 1/2.
Yeah, because 5 1/2 is the same thing as 5 plus 1/2, right? So let's do that. 5 and 1/2. Now, we said one of the benefits of the area model is that we can choose what to multiply together. What do you want to start off? What could we multiply first? Go for it.
10 times 5.
10 times 5 equals?
50.
Great. Let's do another one. Yes, sir.
1 times 5.
1 times 5. Going for that easy money here. What do we got? 1 times 5 equals?
5.
Great. Okay. What can we multiply next?
10 times 1/2.
Oh, 10 times 1/2. What do you think 10 times 1/2 is? Or what is 1/2 of 10?
5. 10.
What about 1 times 1/2? 1/2, because anything times 1 is itself. 50 plus 5 is?
10.
Well, 5 plus 5, that's 10. Plus 50 is 60. And we have one more piece to add. 1/2. Ladies and gentlemen, 5th grade Evergreen Elementary just did 5 1/2 times 11. Give yourself a round of applause, ladies and gentlemen. That area model is always going to get you far. Mike, we'll send it back to you in the studio. Take it away.
Done. Thank you, Devin, and the students out at Evergreen School. Home of the Eagles, and we have another Eagle from Berkshire Elementary. You have Jazmin in studio. Did you have a good time today?
Yeah.
You get some math done with your homework and stuff like that?
Yeah.
All right, well, here's what you are now. You are now an ambassador for Do the Math, and that means you have to go around in this every single day at Berkshire and tell everybody about Do the Math. Can you do that?
No, because I don't wash clothes every day.
You know what? Well, you know what?
don't
I don't
wash
do it every day
clothes.
either. So you know what? As long as you do it once in a while, can you do that?
Yeah.
All right, there we go. Nicely done. A done deal there. Hey, you know what? We have phone tutors available until 5:30. Don't forget, you can also email those questions. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.